So hello everyone, I welcome you all to this amazing platform of PW Gulf, and this is your math educator Shivangi Rajput. And in this particular video, we are going to cover our introduction to Euclid's geometry in one single shot. So as many of you are already aware about that this particular chapter is one of the theoretical chapter in mathematics where you have to deal with the axioms, postulates and certain theorems of your Euclid's. So let's begin with finding out the very first thing that is target for the day. So we are going to learn about the introduction, the axioms and postulates of Euclid, Euclid axioms, Euclid's 5 different postulates. Then we are going to learn about some terms that are related to geometry, incidence axioms on lines, collinear points. Then we are going to learn about intersecting lines, concurrent lines, plane theorem and some important question. So basically all these are the topics that we are supposed to cover today, and basically the axioms, they are just something that needs to be understood, right? Postulates, theorem, those are day-to-day things, right? Those are things that you actually know, but who stated that, who brought that into mathematics? So this is something that we have to understand. So let's begin with the very first thing, that is particularly introduction to the chapter. Right? So basically when we talk about geometry, students, we talk about a lot of things. For example, the very basic thing, that is point. After point, we learned about lines, segment, intersecting lines, ray, concurrent line, coincident lines, all the lines, right? Apart from lines, we have plane. So all these are the things that we are going to understand in this particular chapter. Basically, this chapter involves and basically revolves around some basic fundamental knowledge of mathematics, which we are going to learn as it what are the theorems, what are the postulates and what are the different things that we are going to do. So for here, the axioms and postulates. So first of all, let us understand what does this word axiom and what does this word postulate means. So first of all, self-evident true statements used throughout mathematics and not specifically linked to geometry are called axioms, right? Basically in English, what we call as facts, universal facts. The sun rises from the east, universal fact, right? So basically all these are the things that do not need any proof. These are facts, self-proven, self-evident, which does not require any of the proof. So such things are called axioms, right? An axiom is the word that is given where this particular word or any particular axiom can be used throughout the mathematics, not only in the geometry portion, right? But when such specific geometry thing, right? So basically when any of the axiom, when we talk about any of the axiom and that axiom is specifically used only and only in geometry, that portion of mathematics which is known as geometry, so that part is known as your what? That is known as your postulates. However, we nowadays do not distinguish between axioms and postulates. Both are used on the same thing, right? So basically axiom and postulate is what? One or the other same thing. Axiom can be used in any different part of mathematics also, but when we call it a postulate, that means it is only and only confined to that geometry part. First statement. Secondly, these are self-proven. These does not require any of the proof. This is very self-evident and we can say common sense or we can say universal fact and so on, right? So the very first thing that we have is these are the Euclid's axiom, right, which we are going to learn about. 7 are here on the screen. We will understand these one by one. So the very first postulate is things which are equal to the same thing are equal to one another. Very easy thing. For example, let's begin with an example of a circle, right? Let's take example of a circle. For example, this is a circle, right? If I draw one more circle and let me say that this circle is equivalent to this circle. And let me draw one more circle, that is the third circle. So what I am saying that this is circle A, this is circle B and this is circle C. Right? So if I tell you that A is equals to B, that circle A is equal to circle B, and then I call that B is equals to C, that means circle B is equivalent to circle C. So what can we see? That A is equals to B and this B is equals to C. So what can we say? That this A is equivalent to C. So from 1 and 2, we can calculate that A is equals to C. So what does this mean? That things which are equal to same thing are equal to one another. For example, A was equals to B, C was also equals to B. So both of them were equal to one thing. So they will be equal to one another. The very first axiom of Euclid. The second is, if equals are added to equals, the wholes are equal. Let's take the numbers. For example, we know that 7 is equals to 7. Everyone is aware about it. That number 7 is equivalent to number 7. Right? So these are equals. Now if I add equals to both the sides. For example, in both of these, if I add a plus 3 over here and a plus 3 over here. Right? The very first thing, 7 was equals to 7. The next thing, plus 3 plus 3. Same thing is added to both the sides. So now whatever the result we will get, that result will also be equal. As simple as that. This is Euclid's second axiom. Now the Euclid's third axiom says, if equals are subtracted from equals, the remainders are equal. Again, simple thing, students. See, we know that 10 is equivalent to 10. Right? Now from both the side, if I subtract 5, 10 and 10 were equal, negative 5 equal. If equals are subtracted from equal, the remainders, that is the result that we get after it, are also equal. So what can we say? That if equals are subtracted from equals, the remainders are equal. The next is, things which coincide with one another are equal to one another. What does coincide means? Where the starting and the end point is same. For example, if I draw a line. For example, this is a line of 8 centimeter. Then let me draw one more line like this. As we can see, it is coinciding. What does coinciding means? Overlapping. Overlapping means the starting and the ending point of both the pink and the green line over here is same. So we can say that both of them are equal. So the pink line will be equivalent to that of the green line. So this is the fourth postulate axiom. The fifth is, the whole is greater than the part. Very simple thing, right? So we all love to eat pizza. Right, of course, we all love to eat pizza, and when we are eating it, so we always see that it comes into slices, right? For example, we have ordered a large pizza of 8 particular slices, right? Let's make some toppings. Alright, so if I were to give you one of these slices, right? If I were to give you one of these slices, what I'll do, just pick one and give it to you, and that slice will somewhat look like this, right? And we know that this part of that pizza, this slice of the pizza will always be smaller than the whole pizza, right? If I have an apple, if I cut it into half, if I give you the half apple, right? So that half will always be smaller than the whole apple. So what does it say? The whole is always greater than the part. That for whatever whole thing you have, and if you take out a piece of it, so that piece will always be smaller, and we can say that the whole will always be greater than the part of it, or we can say the slice of it, the part of it. Next we have, things which are double of the same thing are equal to one another. That means what? For example, I have a line segment, and this line segment is of 1 centimeter. Now for this line segment, I have drawn one more line segment, and this line segment is 2 centimeter. That is double of it. And for the same thing, I have drawn one more line segment. So basically this line segment is double of 1 centimeter. This line segment is also the double of 1 centimeter, that is 2 centimeter. Now this was our base 1 centimeter. Once I have drawn a line segment of 2 centimeter, the other side I have again drawn a line segment of 2 centimeter. Now what can I say that if this 2 centimeter is double of 1 centimeter and if this 2 centimeter is also the double of this 1 centimeter, so I can clearly say that particularly that both of these lines will be equal. If both of them are double of this, so both of them individually will be equal to one another. This is what axiom 6 states. The last axiom that we have is things which are half of the same thing are equal to one another. For example, let's take the example of an apple. For example, I have an apple. Now what I did, I gave half to you and I gave half to some other students, right? Now this is the whole apple. This part is half of the apple, right? This part is what? Half of the apple. This part is also half of the apple. So if both of them are halves of the same thing, so both of them will be equal to one another. So this is simple axiom number 7. So I hope that all these 7 axioms are clear with you people, right? Let's go forward. Now we have some illustrations, and what are these illustrations? The first one says if the area of a triangle equals to the area of rectangle and the area of rectangle is equivalent to your area of square, then the area of the triangle also equals to the area of square. Let us see how we can draw it. First of all, we are saying if the area of a triangle equals to the area of rectangle, right? That means that the area of a triangle is equivalent to the area of a rectangle, right? We can say that area of a triangle is equal to the area of rectangle and the area of rectangle is equivalent to the area of a square. So what can we see over here? Triangle equals to rectangle, rectangle equals to square. So we can say that the area of triangle will also be equal to the area of square. As simple as that. The next illustration that we have is magnitudes of the same kind can be compared, added or subtracted, but magnitudes of different kinds cannot be compared. For example, kgs with liter cannot be compared. Centimeter with kilogram cannot be compared. So the unit have to be same, the quantity have to be same, and the kind have to be same. The magnitudes of different kinds cannot be added and subtracted. The next we have is everything equals itself. This is for sure. If this pen, if I were to get one same pen, or if I have to duplicate it, so that duplicated pen will always be equal to the original pen that is here in my hand. The next thing that we have is if A is greater than B, then there exists a quantity C such that A is equals to B plus C. Now what does this mean, students? Listen to me very carefully. For example, A is equals to B. Let us take numbers. We know that 10 is greater than 6. For sure. This is our A and this is our B. What I have written that A is greater than B. For example, 10 is greater than 6. Everyone agrees with it. No one will not agree, right? Then there exists a quantity C such that A is equals to B plus C. Now, for example, if I have to write down that A is equals to B plus C, that means 10 is equals to 6 plus what? 6 plus 4, right? So, if one number is greater than the other number, so there always exists one other number which I can add to B so that both the A and B plus C will be equal to one another. I hope this thing is clear with everyone. The next thing that we have is postulate 1. A straight line may be drawn from any one point to any other point. Euclid assumed that there is a unique line joining two distinct points. So we all are aware about that if we are given two different points in a plane, right? For example, if this is the plane that we have, if one point is this and the other point is this, students, so in between these two different points, we can only draw one single straight line, right? The next postulate that we have is a terminated line can be produced indefinitely. In present day term, we say that line segment can be extended on either side to form a line. For example, I have a line segment of 8 centimeter. I have drawn it. Now then I realize that no, I have to draw a line segment of 10 centimeter. I can extend it and form 10 centimeter. So what does this postulate say over here, students? That this particular AB line segment can be extended to any possibility, to any furtherness, right? So we can extend any line segment from both the ends so that it forms a line. Next we have is a circle can be drawn with any center and any radius. For example, if I have to draw a circle here, I can draw a circle here, I can draw a circle here, I can draw a circle here, anywhere. That means any center. With any center, I can draw the circle and of any radii also. This is also a circle, right? And of any radius we can draw the circle. As simple as that. Postulate 4 that we have is all right angles are equal to one another. All right angles are 90 degree. 90 degrees always equals to 90 degrees. So what it says, all right angles, that is 90 degree. A 90 degree is always equivalent to 90 degree, and that's how we are going to do it. I hope this thing is clear with everyone. Let's move forward to the next. Alright, so this is important because it has a specific name and they can ask you in the exam if this chapter is coming, that state the Playfair's axiom or state postulate 5. So be aware about it. If a straight line falling on two straight lines makes the interior angles on the same side of it taken together less than 2 right angles, then the two straight lines produced indefinitely meet on the side which the sum of the angles is less than 2 right angles. Now what does this mean? For example, if I have a line, right, now on these two lines, if I were to draw one line like this and the other line like this, right, these are not the right angles. And of course, this angle is very much clear that this is more than 90, students, more than 90. This angle will be less than 90. This angle similarly will be less than 90. This angle will be more than 90. Now when we talk about the interior side of the angle, students, so this means the interior side of the angles, right? Now if there are such two lines, so of course it is very much visible that if I were to extend these two white lines, I can extend it either ways, right? Either I can extend it to the downside, for example here and here, or either I can also extend it to the upside, that is here and here. So it is very much visible, student, it is very much visible that where will these lines meet? Of course, it will meet where the sum of the angles or different angles are always less than 90 degree. So this is a Playfair's axiom, or we can say postulate 5. Let's move forward to the Euclid's 5 postulates now. Right, so these are the 5 postulates. The very first says a sentence which can be judged to be true or false is called a statement. So in an entire life we have done true and false, right? Is 0 a natural number? True and false. Is 1 a whole number? True and false. Every integer is a rational number? True or false. All rational numbers comes under real numbers? True or false. So all these statements, right, all these sentences, basically if I say, all these sentences that can be judged. Now what does mean by can be judged? It means that where we can say that yes, this is right or this is wrong, right? In the courtroom, when we have any issue, we go to the Supreme Court, the High Court and whatnot, right? So in the court, there is a judge, right? Why is he known as a judge? Because he judges for the sentences that the victim or the guilty person is speaking is either true or false. Either he is speaking the truth or the lie. So basically, every sentence that can be judged for being true or being false is called a statement. Right? So this is known as a statement. The sum of all angles of a triangle is 180 degrees, a true statement. The sum of all angles of a quadrilateral is 180, false statement. X plus 10 is greater than 15 is a sentence but not a statement, right? Why? See, this is a sentence and not a statement. Why? Because we cannot judge it. Because it can be true also, it can be false also. Because if x is 0, so 10 will not be greater than 15. If x is 1, then 11 is not greater than 15. If x is 2, 12 is not greater than 15. But if x is 6, so 16 is greater than 15. So it totally depends on the value of x. So basically for the statements, for the sentences where we cannot say that whether it's true and false because it is dependent on any third party, any third variable, right? So such sentences are not called statement, they remain as sentence only. Alright. Next, a statement that requires a proof is called theorem. See, now statement is a thing. Statement is what? True and false. If true, so we have to prove it. Same happens in the courtroom, right? You present your party. If you are saying the truth, you have to put some evidence. If you are saying that no, the other person is saying the false thing, you have to put a proof in that. So all the statement that requires a proof are called theorem, that we deal in geometry. Theorem 1, theorem 2, theorem 3 and so on. The next thing that we have is a point has an exact location. Of course, if I were to draw points on any part of this board, so all these points as per coordinate and as per geometry also have what? A specific, they tell us a specific exact location. Next is line segment, a straight path between 2 points A and B. What is line segment? We have learnt about it in junior classes too. So a line segment is a fixed length, a part of line, right, and a straight line between two definite points. The next we have is a line segment AB when extended indefinitely to one direction is called a ray, right? So when a line segment is extended to one direction, it is called a ray. The next we have is a ray has no definite length, of course, because sun rays, right? We can totally relate it with sun rays. What happens that when we have sun, alright, so what happens is if we have a sun, right, and over here it has rays, these are known as rays. Why these are known as rays? Because the starting point is fixed, that is the sun, but the end point is not fixed, that is by a ray. So what is a ray, student? Which has a starting point but not a fixed ending. So of course if it does not have a fixed ending, that means what? It does not have a definite length. The next thing that we have over here is simply that if it is extended to both the direction, then it is called a line. A line has no endpoints, it has no definite length, and a line can be drawn to represent any plane on the paper. Next, alright, let A, B, C half lines. What are half lines? Divided by midpoint. Let A, B and C be any 3 points on a given line L such that A lies between B and C. Then each of the remaining parts, namely AC and BC, are called the half lines, right? Of course, divided into 2 equal parts. A line contains infinitely many points. So what is a line specifically when we talk about? It is a collection of points, right? So of course if it is a collection of points, so there are many small points that are present in between the line, which combines and form your line. And from one single point, students, infinitely many lines can pass through one single point. Next that we have is, through a given point, infinitely many lines can be passed. We have already discussed about it. And one and only one line can be drawn through 2 points A and B, right? If 2 points are given to us, so from and through these 2 points, only one line can pass through these 2 given points. The next we have is 3 or more than 3 points are said to be collinear if there is a line which contains them all. That means if one single line passes through those 3 points, then the points are called collinear. For example, 1, 2, 3, and for example 1, 2, 3. Now in the very first example, student, this line can pass through all the 3 points. So these 3 points are called collinear. Now in these 3 points, there is no such one line which passes through all 3 of them, right? There is no such one line that passes through all 3 of them. So basically these points are what? These points are called non-collinear. Collinear, non-collinear. The next we have is 2 lines having a common point is called intersection, right? So this point is called the point of intersection, intersecting lines. Next, 3 or more lines intersecting at the same point are called concurrent. So what are concurrent? If 2 lines are crossing each other, intersecting lines. If 3 or more lines are passing through one common point, that is like this, so such lines are known as concurrent lines. The next that we have is a plane is a surface such that every point of the line joining any 2 points on it lies on it. The surface of a smooth wall, the surface of the top of a table, if you are studying in a room, your wall, your roof, your ceiling, right, your floor, everything is a plane. The next thing that we have is theorem. Then first theorem states that 2 distinct lines cannot have more than 1 point in common. Of course, if we have 2 different lines, like for example 1 line and 2 line, right? So these 2 lines cannot have more than 1 point in common. It is not possible. The next thing that we have is that the lines which are parallel to a given line are parallel. For example, if this line is parallel to this line, and if one more line like this is parallel to one, so all 3 of them, students, all 3 of them will be parallel to each other. The next thing that we have is if line AB, AC, AD and AE are parallel to line L, then the points A, B, C, D, E are collinear. That means what? If AB is a line, AC is a line, AD is a line and AE is a line are parallel to L. Means all these lines are parallel to one single line, that is L. So of course A, B, C, D, E are collinear. That means they all lie on a same straight line. Alright, so the question will come like this. If A, B and C are 3 points on a line and B lies between AC, show that, then prove that AB plus BC is equals to AC. Right? See, if these are 3 points and B lies in between AC, if B lies in between AC, so we can say that AB is equals to BC. Right? Now what we do, we simply can do what? Basically, we have to prove that AB plus BC is equals to AC. Right? Now, basically, if this is the midpoint, so AB is equals to BC. So what we can say that if it is already the midpoint that is given to us, right? If it is in between it, right? It is the midpoint of that line. So that has to be. So basically this AC line is already divided into 2 parts, that is AB plus CB. That means if one point is there, this is what? Axioms of Euclid. So by axiom of Euclid, we can clearly state that. The next is true and false. Only one line can pass through one single point. This is a false statement, student. Why? Because if one single point is given, infinitely many lines can be drawn through it. The next we have is there are infinite number of lines which can pass through 2 distinct points. Now this is again a false statement. Why, students? Because if we are given 2 distinct points, so only one line can pass through 2 distinct points. Next we have is a terminated line can be produced indefinitely on both the sides. So this is a true statement, because if we have a line segment, so such a line segment, students, can be extended to both the side and then we can draw it clearly. The next thing that we have over here is If two circles are equal, then their radii are equal. What does this mean? That if we have two circles, 1 and 2, if they both are equal to each other, then of course their radii are equal to each other. So this is what? A true statement. Right? Alright. The next thing that we have is, if AB is equals to PQ and PQ is equals to XY, then AB is equals to XY, of course. If one thing is equal to other and then that thing is equals to the third thing, so the first thing will be equal to the third thing. True statement. Alright, we have to say that if a point C lies in between 2 points A and B. Alright, so what we have to say, that this is a line AC, right, and no, this is a line AB, and a point C lies between such that AC is equals to BC, then we have to prove that AC is equals to half of AB. First of all, we can say that AC plus CB is equals to AB. Right, in the place of CB or BC, we can write AC as both of them are equal. So AC plus AC is equals to AB. Twice of AC is equals to AB, and then AC is equals to half of AB. So this is what we were supposed to prove, and this is it. The next is saying that, see, in the given figure, AC is equivalent to BD. Now, what is it saying? That in the given figure, if AC is equals to BD, then we have to prove that AB is equals to CD. See, first, AC is equals to BD. Equals. Now, subtract equals. That is, from both the sides, subtract BC. Minus BC, minus BC. See, AC minus BC will give you AB, and BD minus BC will give you CD. So this means if equals are subtracted from equals, the answer is again equal. So it is an easy chapter, and you just have to look forward to certain theorems and postulates and axioms. Playfair axiom is important, so please have a look forward to it. And if you have any doubt in this chapter, feel free to comment down. I will be more than happy to help you out. So I hope that this lecture has helped you, cleared all the axioms and postulates from your mind, and we will be back with another one short lecture of the next chapter. Till then, take care. Have a great time ahead. Thank you so much.